Greetings everybody. Today I'll show you a project with a neuronal network used to analyze a data corpus of human movement. To develop this project we used Python and Jupyter Notebook along with, with some libraries such as pandas that allows to read and modify the data of a file. To read a file we need this method here, this line here, where we receive the name of the file we want to read, as well as the name of the columns we want to give to the columns. And this library also allows to handle the data due to having information that doesn't is needed for analysis. We can drop this information with this line here, where we send the name of the columns we want to eliminate. We can also transform the data from a string, as we have here, to a number. It is important thanks to the neuronal network needing a number value to work properly. It cannot work with strings, with text. We can also use scikit-learning. This offers a lot of models, as you can see here, to develop and run the neural network and to graphic the learning curve. We also need a keras library here, and specifically this method of two-categorical. This allows to transform the result data or the possible results to using hot encoding. It means show a value, a numeric value or a string value as a binary value, a collection of ones and zeros. It allows to improve the precision of the network. And finally we have the BizNet library here, which is used to draw a diagram of the network that we're going to be using. Now, how the program works? We start reading the corpus, reading the file. As I have said, we have this method here that receives the name of the file, and it shows here a heading or the first bytes of the file. Next we have the mapping that allows to transform this data into numeric values, such as here, and this method here that helps drops the data that we're not using. So you can see in here we are already printing the values modified values. As you can have here, the column 2 we have that originally it have this series here, but now we have 2, 1, 3. Now el transpose gives a statistic value of the data contained in the file. This separation method, it is working already in the network, in the neural network, separating the data in the train and the test. Now we have this method here that shows the diagram of how will be the network. As we can see here, we have 7 neurons of entry. We have 5 fields, 5 capes, 5 hidden layers, each with 50 neurons, and 1 exit layer with 1 neuron. This diagram is confusing because some trouble configuring it, but it's supposed to show us the network. Now we have here the characteristics of the network we will have in width. As you can see, we have the 5 hidden layers with 15 neurons each, a maximum of 1000 tries to or cycle of 1000 iterations to train the network. The beta, the error, no, here, the error, and this method, this project is a lot or take a lot of time. So I have run it before to avoid pausing the video. But we have here that gives us a precision of 77%. And we have the confusion matrix here. Finally, we have the learning curve. It's also a very slow process since it practically runs the training again, and we have here how the network is learning about the data. It is important to note that at the end it cannot keep perfectly horizontal, since it means the network is being overall training over this data and won't work on others' data. And as I have said, this project consumes a lot of time, at least in my computer with my specifications, or with the characteristics of my network, since it runs about 100 minutes. It's almost 2 hours that takes to run the project. And that will be all about the project. Thanks for watching, and goodbye.